Okay, guys, once again, welcome to my lesson for today. Obviously, most of you know my name is Desmond. So, guys, it's very much important that I say it's very, very much important, ladies and gentlemen, because what I'm about to say is massively important. So, guys, a day without learning something new, it's a day wasted. So please do make sure that by the end of each and every lesson that I conduct, you learn something new. So guys, I won't waste much of our time. So for today's lesson, we'll be looking at Physical Sciences, paper 1 of November 2017. So ladies and gentlemen, at all times, you are advised to start each question on a new page. So as you can see over there, you are told to start on a new page. So we'll be looking at question 3 of this question paper. So what I'm going to do is to quickly read through the given statement, do a little bit of interpretation, go through all the questions that follows after that statement. And most importantly, ladies and gentlemen, I'm going to redraw that diagram and again do a little bit of interpretation. Similarly, I'm going to go through all of this information which is in relation to that given diagram. So ladies and gentlemen, please do make sure that you pay full attention. And most importantly, if you are able to listen and write at the same time, you can still listen and write. But otherwise, if you are not able to listen and write at the same time, you can just watch the lesson. I'll make sure that it's available on my website. So just in case, if for some reason you're watching this lesson on my YouTube channel or any other social media platform and you are not part of this lesson, just know that it will be uploaded on my YouTube channel. Otherwise, you can also access it on my website. So guys, let me make use of this opportunity to read through that given statement. And remember, guys, in case if you've got a question, you can just immediately dive in and ask any question before I go far with the lesson. And again, if you notice you're not able to see something that I'm writing, or otherwise, if the screen it's a little bit blurry, you can also make a comment to that so that I make adjustments to the lighting. So guys, a stone or stone A is projected vertically upwards at a speed of 12 meters per second from a height h above the ground. Ignore the effects of air resistance. So ladies and gentlemen, be careful of the given statement or otherwise the arrangements in which the statement together with the information or the diagram is arranged. As you can see over there, we are given that mini statement followed by a question. So ladies and gentlemen, do not read that statement and straight away go to this diagram, because before you even get to this diagram, you still have that question to answer, which is based on that mini statement given over there. So I'll just read it for the last time. Stone A. So that means we've got a stone which is named stone A, which is projected vertically upwards at a speed of 12 meters per second from a height h above the ground. Ignore the effects of air resistance. Before I even check that diagram, ladies and gentlemen, based on this statement, I should be able to notice that we've got a certain height. This is the height that they are referring to. That's why I'm saying it's a certain height, of which we've got stone A, which is being projected vertically upwards. Obviously, this is the initial velocity of that stone A. So it's being projected vertically upwards at a speed of 12 meters per second from a height h above the ground. So obviously, above the ground, that level, this is out. So one thing for sure, you are aware that that object A, it's not being projected vertically upwards from the ground, but instead it's being projected vertically upwards from a height h, which is that height h, which is above the ground. At what speed? At 12 meters per second. So ladies and gentlemen, before we even have a look at the question, remember, most importantly, ignore the effects of a resistance. Okay, so ladies and gentlemen, what information do we know? Obviously, we know at some point this object is going to reach its maximum height. That's one thing for sure. An object projected vertically upwards, regardless of its initial velocity, we know at some point it's going to reach its maximum height. Most important, ladies and gentlemen, what happens when an object reaches its maximum height? It momentarily stops and changes direction. I assume at this point in time, we do know very well that an object projected vertically upwards, it's going to reach a maximum height where it momentarily stops and now change direction. Ladies and gentlemen, we know that at that maximum height, this is where its final velocity is equals to 0 meters per second. 0 meters per second. So ladies and gentlemen, from 12 to 0, what does it tell? It means as this object A or any object projected vertically upwards, as it goes up, ladies and gentlemen, its velocity decreases. So that means from 12 it starts decreasing. It could be 11.9, 11.8, 11, 9, 8, 7, 6, 5, 4, 3, 2, 1, up until it's 0. So obviously when it's 0, that's why I'm saying it momentarily stops. It stops for a moment. Then from there, it changes direction. Guys, very, very much important. There's something which is influencing the speed of that object. Why is it decreasing its velocity as it moves upwards? It's because of that force of gravity, ladies and gentlemen. Obviously, you know gravitational acceleration, it's constant, always exiting downwards or towards the center of the earth. Okay, so ladies and gentlemen, obviously in this case, assuming that upwards is positive, obviously downwards it's going to be negative. So whatever that you assume in the opposite direction, the opposite is the case. Meaning, if you assume upwards to be negative, then it means downwards will be positive. But in most cases, ladies and gentlemen, especially in my case, I normally use upwards as positive, downwards as negative. But for the purpose of this lesson, we'll do both calculations where we assume upwards to be positive and do the second calculation where we assume downwards to be negative. So ladies and gentlemen, let's have a look. Obviously, if we assume upwards to be positive, then it means our G is going to be negative. Why is it in negative? It's because, ladies and gentlemen, if this is the earth, we've got continents there, we've got provinces, we've got oceans, we've got everything, ladies and gentlemen. G always exerts towards the center of the earth or towards the ground. So, ladies and gentlemen, at all times, G is in one direction. What changes is the sign of positive or negative. Remember, in physical sciences, the sign represents the direction. Okay, so I'm just going to give you a quick example so that you understand what we mean when we say in physical sciences a sign represents the direction. Remember, guys, this object is being projected vertically upwards at an initial velocity of 12 meters per second. It reaches its maximum height, it momentarily stops, and then it changes direction. So, guys, as soon as that same object A reaches that point, which is on the same level as where it was initially projected vertically upwards, obviously, as it goes up, its velocity decreases up until it's zero. From there, ladies and gentlemen, it goes down, changes direction. Its a velocity starts to increase in the downwards direction. And when it gets to that point, its velocity is the same as its initial velocity, meaning if it was projected at 100 meters per second, it will be 100 decreasing 30, 20, 10, 0. Then from there it starts to increase 10, 20, 30, 40, 50, 60, 70, 80, 90. When it gets to that point, it's now 100. So I want you to notice something, ladies and gentlemen. So since its V initial in this case, it was 12 meters per second, assuming that upwards is positive, then it means its initial velocity is positive 12. Okay, so now what about that velocity over there? So that velocity being final velocity from there to there, its velocity will be negative 12 meters per second. So I want you to notice something. Remember, velocity is what we call a vector quantity. A vector quantity, it's a quantity that has both magnitude or the size, which is that value of 12. It's a magnitude, or otherwise is the size, is the amount, ladies and gentlemen. And again, a vector quantity, it has a magnitude and a direction. So in physical sciences, a direction is represented by a sign of a positive and a negative. So ladies and gentlemen, do not say this amount or this velocity is less than that velocity because this is a negative number and that is a positive number. Okay, ladies and gentlemen, is the same number. The only difference is the directions, which is represented by a positive sign and also a negative sign. Okay, that's why this is still the same as a 12 meters per second upwards. This is still the same as 12 meters per second downwards. So that means we've got multiple ways to represent direction in physical sciences. You can represent the direction by using a sign of a positive or otherwise a sign of a negative. Secondly, you can use that word to say upwards or otherwise that word to say downwards. Okay, massively important, ladies and gentlemen. So guys, before I continue, are we still on the same page? And again, are you able to clearly see on the screen and also hear my voice? Can someone just confirm for me that part before I continue?
Yes, we can, sir.
Okay, 100%. So now, let me remove all of this information. Then from there, we'll start to look at the first question. So, ladies and gentlemen, they say calculate. This is question 3.1, which is allocated 3 marks. Calculate the time taken for stone A to reach its maximum height. Ladies and gentlemen, in each and every question, there's a cream of the question. What is the cream of the question? The cream of the question is that weight or those weights when removed from a question, the whole of that question becomes senseless. So, ladies and gentlemen, remember, we are now on question 3 and we're looking at question 3.1, which is allocated 3 marks. So, ladies and gentlemen, what is the cream of that question? There must be that word when removed on that sentence. You won't be able to know exactly what the question wants you to calculate. So, ladies and gentlemen, let's have a look. Calculate the taken for the stone A to reach its maximum height. So, ladies and gentlemen, if I hide or remove that word time, can you see? You remain with that question as calculate the taken for the stone A to reach its maximum height. So, if you've done a lot of this type of questions, you might be able to understand exactly what the question wants you to calculate. But in short, I'm trying to say time is the cream of that question. Why is it important for you to identify the cream of the question? It's because it helps you to know how your final answer should look like. So, ladies and gentlemen, in answering that question, we should not give anything other than time, which is measured in seconds. Very, very much important, ladies and gentlemen, because sometimes if you just read a question and let's say you're doing this question towards the end of let's say you're doing this as your last question. Remember, I think you're allowed to start with any question that you like. Let's say you are only left with 5 minutes and you're doing this question 3 as your last question. So you get to that stage where you just try to read as quick as possible and you only concentrate on that last part which says its maximum height. Then you say, okay, maximum height, they want the height. You perform some calculations where you say your height is equals to 2 meters. So, ladies and gentlemen, can you see? The height is not the cream of that question. So the question wants you to calculate the time taken for stone A to reach its maximum height. So time is the cream of that question. Anything else is just to guide you in terms of which time the question wants you to calculate. So guys, as you practice this, just do this type of exercise where you try to identify the cream of the question. Massively important, ladies and gentlemen. So now let's try to answer that question. Okay, so before I answer that question, let's quickly try to redraw that statement or to represent that statement diagrammatically. So we've got that height, we've got let's see, we've got object A. Obviously, we know it's going to reach its maximum height where its V final it's equals to 0. And we were told its V initial it's equals to 12. And most importantly, at all times, we know G is always there as 9.8. You just need to be careful in terms of the sign, whether your G is positive or negative. So now here comes a question. How do you know if your G is positive or negative? Ladies and gentlemen, an answer to that question depends on your decision to take upwards as positive or negative. If you take upwards as positive, then it means this will be in the opposite direction. Okay, massively important, ladies and gentlemen. If you take upwards as negative, then it means this is going to be an opposite sign. Very, very much important, ladies and gentlemen. And also, it's very, very much important that you make a note to say up as positive. Okay, so that at the marking center they are able to know that for your calculations you assumed upwards to be positive. It makes it very much easy for us to mark in the marking center. Ladies and gentlemen, very, very much important. So guys, I also want you to notice something. Let's just assume this is the ground. So ladies and gentlemen, remember, when it comes to this chapter, it's very, very much important that you are able to identify just three quantities. So if you know three quantities, you will be able to calculate the fourth quantity, of which in this case, it's time. So ladies and gentlemen, time is what they want you to calculate. Okay, so once you've identified to say your V initial, because you assume upwards to be positive, then you've got positive 12. Ladies and gentlemen, that maximum height over there, it's 0. So I'm going to ask this question on your behalf. Is that 0 positive or negative? Ladies and gentlemen, that 0, it's a positive 0. Positive 0 meters per second. That 12 is positive 12 meters per second. Obviously, that G is going to be negative 9.8. This is negative 9.8 meters per second squared. That is the unit for measuring the acceleration. In this case, we call it gravitational acceleration. So, ladies and gentlemen, time is what we call a scalar quantity. What does it mean? Time has got no direction. You only have a magnitude or a value which is measured in seconds. Very, very much important, ladies and gentlemen. So guys, let's now perform the calculation where we assume the positive to be upwards. Obviously, guys, now that we know our three quantities and we now calculate the fourth quantity, from here we go to the formula sheet to check for that formula that has got V final, V initial, gravitational acceleration, and time. Ladies and gentlemen, let's go to our formula sheet and look for that formula. And guys, please do make sure that you familiarize yourself with this formula sheet. Do not only use this formula when you're writing your final exams. During my times, ladies and gentlemen, I knew these formula sheets by heart. I did not have to refer to this formula sheet when I was answering these questions, because I've done a lot of problems up until I got to a point where I know how these formulas look like. So ladies and gentlemen, let's try to look for that formula. As you can see, guys, the first formula, we've got V initial over there. We also have it on our problem. We also have V initial over there. And again, it seems like we've got G over there. Remember, in this case, that A represents acceleration. What type of acceleration are we dealing with in this case? Guys, it's what we call a gravitational acceleration. And again, we've got time, which means we can use that formula, ladies and gentlemen, to do our calculation. So in this case, let's just assume up to be positive. We'll also perform another to be negative. Okay, so ladies and gentlemen, when we perform both of these calculations, we should find the same answer. So obviously, guys, we noticed this is the formula that we can use. Then there you can say G delta T. Okay, so ladies and gentlemen, before I forget something, remember I've asked myself to say that 0, is it a positive 0 or a negative 0? Remember, guys, even if it's a positive 0, It's just to convince yourself that we are now dealing with that object where it reaches its maximum height from that point going upwards. Okay, so even if you punch positives 0 on a calculator, it's still 0. That's why in class your teacher may just write 0. Okay, and again, ladies and gentlemen, in case if you assumed upward to be negative, that 0, it can still be negative 0. Same as 12, it's going to be negative 12. Ladies and gentlemen, negative 0, when punched on a calculator, it's still 0. So in your mind, you can say it's a negative 0. Why? Because you know you assumed upwards to be negative. So ladies and gentlemen, I just had to explain this so that when we substitute on the formula, it makes perfect sense. So now let's do the substitution. I'm sure some of you have already done this calculation. So ladies and gentlemen, our V final, is it positive 0 or is it negative 0? Ladies and gentlemen, we assumed upwards to be positive. That means it's a positive 0. But there's no need for us to say positive 0 because we know positive 0 on a calculator, it's still 0. So ladies and gentlemen, what about our V? Is it a negative V or a positive V? It's obviously a positive V. Why? Because we assumed upward movement to be positive. So this is where you can say either positive 12 or just say 12 because we know positive 12 is the same as 12. Okay, so plus, ladies and gentlemen, what is our G? Is our gravitational acceleration in the same movement as that object which is being projected vertically upwards? And answer to that question, it's no. What does it mean if they are not in the same direction? It means if this object is going upwards, this is going downwards. And still, when that object returns downwards, G doesn't change its direction, it's still towards the center of the earth, or otherwise, it still exerts downwards. Which means when we substitute, ladies and gentlemen, it's negative 9.8 over there is delta t, which is what we are calculating. Okay, obviously, to perform this calculation is very much easy, ladies and gentlemen. I've done a lot of lessons where I teach solve for x. So for you to be able to understand solve for x is to help in these cases where you know that you've got an equation where you must solve for the unknown. What is the unknown? In this case, the unknown is delta t. Okay, so that sign delta, ladies and gentlemen, do not get confused by that sign. It's delta, it's the Greek word. So delta simply means change, ladies and gentlemen. Change in physical sciences, we know it means final minus initial. Okay, so there we know in our mind we are simply calculating for time. Okay, so for it to be changed in time, I will explain that on some other lessons so that you're not confused. So obviously you transpose, you've got negative 12, which is equals to negative 9.8 delta t. Ladies and gentlemen, you divide by negative 9.8. What you do on the left, you also do on the right. Why did you have to divide by that? It's because you want to cancel so that you just remain with delta t. Ladies and gentlemen, when you punch this on a calculator, what value are you getting? So I'm quickly going to punch that value over negative 9.8. At the top is 12. It's negative 12 divided by negative 9.8. So ladies and gentlemen, this is the value that I'm getting. Most important, ladies and gentlemen, at all times, remember to write the SI units. the international symbol unit for measuring time. We know in physical sciences, we measure time in seconds. Okay, by so doing, ladies and gentlemen, you score yourself full 3 marks. What I like about physical sciences is that they give you a mark for correct formula. Okay, from there, after writing the correct formula, ladies and gentlemen, I think you also get a mark for correct substitution. Ladies and gentlemen, from there, you're most likely to score your mark for your final answer. So this is where you score your 3 marks. First mark comes from you identifying and writing down the correct formula. Second mark comes there for correct substitution. Ladies and gentlemen, your third mark comes from your final answer with the correct SI unit. So guys, I'm not sure if we're still together up to this point. Is there someone who's been confused, not understanding, or otherwise, can someone just indicate if all is in order?
All is in order, sir.
Okay, great. So now let's perform a similar calculation, but assuming upwards to be negative. So ladies and gentlemen, you shouldn't be confused by this calculation. Remember, we still use the same formula because we know it has all the variables or all the quantities that we need. So it's just a matter of you playing around with the signs. Okay, obviously, if we assume upwards to be negative, that means our final velocity is going to be a negative 0. Remember, I've just explained there's no need to say negative 0 because when when punched on a calculator, negative 0 is the same as 0. But in our mind, we know this is negative 0. Okay, that can be equated to, ladies and gentlemen, our V initial. Is it in the upward direction or in the downwards direction? Obviously, it's in the upward direction. What sign did we assume for the upwards direction? Ladies and gentlemen, it's a negative sign, which makes it negative 12. Okay. Plus, what about G? Is it a positive or a negative value, ladies and gentlemen? One thing for sure, we know G, it's in the opposite direction in which the initial velocity is heading. Obviously, object A is moving upwards. G is in the opposite direction. That is the reason why we are going to have G in the opposite sign. Okay, being positive 9.8, of which even if you didn't write that positive, we already know it's positive 9.8. Very, very much important, ladies and gentlemen, that you are able to carefully substitute in that equation. Ladies and gentlemen, you perform the same calculation. Transpose, it becomes positive 12, which is equals to 9.8. This is delta t. Obviously, you divide by 9.8 on both sides. Why? Because you want this to cancel so that you remain with delta t, which is equals to, when you punch this on a calculator, you will get 1.22. Obviously, the SI units for measuring time is seconds. Ladies and gentlemen, before we move on with this question, is there someone who's got any question, or in case if there's someone who's been confused by something? Guys, this is that opportunity where you can just ask any questions that you are not clear of before we move on. So same criteria is being used for marking this one. That for the formula, that for correct substitution, a mark for your final answer. So guys, any questions, any comments, anyone who needs clarity somewhere?
We fine, sir.
Okay, 100%. So now I'm going to remove all of this. I'm going to remove all of this. And remember, guys, just in case if my calculation is too long and you're not able to see the last part or the last part of the calculation, just make an indication on that so that I don't keep on calculating whereas you're not able to see. So, ladies and gentlemen, at the same instant, this is where I'm reading. I hope it's not blurry, ladies and gentlemen. I hope everyone is able to see. At the same instant, that stone A is projected vertically upwards. Stone B is thrown vertically downwards from the same height at an unknown speed, being V. Refer to the diagram below. So, ladies and gentlemen, let me quickly try to draw that diagram. So, we've got that object A, which is being projected vertically upwards at a speed of 12 meters per second. Right at that same level, obviously, this is A and this is B. So what happens is that we've got B, which is being thrown vertically downwards at an unknown velocity. So, ladies and gentlemen, all of this, it's at a certain height, which is being called height H. Height H above the ground. So, this is that diagram that we're given, ladies and gentlemen. So, it's up to us to add the correct information over there. So, now let's add what we know. Obviously, we know that object is going to reach its maximum height and then changes direction and move in that direction. And we know at that point its velocity, it's going to be 12 meters per second. No need to say positive or negative. No need to say positive or negative because that depends on me assuming upward to be negative and downwards to be a positive, or otherwise vice versa. So you can just write 12 as long as you know that 12 represent the downward movement. So, ladies and gentlemen, very, very much important. Very, very much important, ladies and gentlemen. We obviously know, we calculated the time it takes for that object A to reach its maximum height. We just calculated the time, ladies and gentlemen, and the time was 1.22 seconds. Guys, for the fact that when this object, as it goes up, its velocity decreases until it gets to that point where its V final it's equals to 0 meters per second. For that fact that as it goes up, its velocity decreases until it's 0, changes direction, get to that same level and have that velocity which is the same as the velocity at which it was being projected vertically upwards. It makes the time to return same time as the time it took for it to reach its maximum height. Massively important, ladies and gentlemen, that at all times you remember this formula. Time taken to go up is the same time taken for it to go down to that same level. Okay, so what does it mean? It means for this object to move up and down to that same level, it takes 1.22 plus 1.22 seconds, which is 2.44 seconds. So for that run and drag, ladies and gentlemen, run and drag to the same level, it's 2.44 seconds. Massively important, ladies and gentlemen, that you fully understand that part. Okay, so obviously, based on that given information, at the same instant, that stone A is projected vertically upwards, stone B is thrown vertically downwards at the same height at an unknown speed, being V. Refer to the diagram below. So, ladies and gentlemen, I want you to notice something. We've got these words being used under this chapter. Thrown, I've explained this on yesterday's lesson. Remember, guys, in case if you're not able to attend yesterday's lesson, you can still catch up on my website, www.solvingexampapers.co.za. So all of the lessons that I conduct on my Telegram classes, I upload them there so that you can catch up. And as we do upcoming problems, I won't have to explain everything over and over again. So just in case, if we do this lesson, if you've never attended any of my lessons, that's where I advise you to go and catch up. Ladies and gentlemen, you won't regret. So guys, this word thrown, the other word dropped, the other word, ladies and gentlemen, released. So we can have an object being thrown upwards or downwards from a certain height. Ladies and gentlemen, we can have an object being dropped from a certain height, being released from a certain height. So dropped and released, ladies and gentlemen, both of these, the initial velocity is 0, okay? Because it's just that from a certain height being dropped. Can you see, ladies and gentlemen, unlike being thrown? So you can notice the difference. For an object which is being dropped, it takes some time for it to strike the ground. But for an object which is being thrown from the same height, but time is different, okay? So be careful of those words. So the moment when they say an object, which is stone in this case, it's being thrown vertically downwards, that means its initial velocity is not 0. Massively important, ladies and gentlemen. So guys, before I start with this information below, is there someone who's got a question, or otherwise is my explanation clear, guys, such that you don't have any questions?
Yes, sir.
So ladies and gentlemen, when stone A reaches its maximum height, the speed of stone B is 3v. Ladies and gentlemen, when stone A, this is stone A, when it reaches its maximum height, the speed of stone B is 3 times. So it's more like somewhere for stone B on its way down. Remember, we are not sure if it's there when it strikes the ground. We are not sure if it's somewhere there, somewhere there, somewhere there, somewhere there. But we just know that somewhere between this height, ladies and gentlemen, where stone A reaches its maximum height, the speed of object B is 3v. What does it mean, ladies and gentlemen? It means v is the initial velocity of stone B. Ladies and gentlemen, it means this can be regarded as the final velocity of that stone B when, massively important, ladies and gentlemen, when object A reaches its maximum height. What happens, or why do they have to link information for B to that information of A? It's because, ladies and gentlemen, they are talking about when the time is 1.22 seconds. Remember, they are saying at the same instant when object A is being projected vertically upwards, this stone B is being thrown vertically downwards, meaning this is the V initial, this is the V final, and we know its velocity is 3 times V after it has traveled for 1.22 seconds. Massively important, ladies and gentlemen. It's very, very much important that you fully understand this part. And remember, guys, remember, with all of this happening, G is always exiting downwards, ladies and gentlemen. G is always exiting downwards. And remember, for G to be positive or negative, it depends on you choosing the downwards or the upwards being positive or negative. So in this case, you can see the movement of ball B is downwards. It's in the same direction as that G, meaning the sign for the V and the G will be the same, regardless of whether you take down as negative, up as positive. Massively important, ladies and gentlemen. So guys, before I remove this and start looking at second question, is there any question in relation to what I've explained so far?
No, sir.
Okay, so guys, that one, no, I assume it answers for everyone. So ladies and gentlemen, I think we might also need to perform same calculations where we assume whatever to be positive and whatever to be negative. Let's assume again a upwards movement to be positive, and again assume a downwards movement to be negative. So ladies and gentlemen, let's perform the first calculation. So obviously we need to check, ladies and gentlemen, we need to check the formula that has got all that information that we need. So remember, guys, I'll just write down that information. Obviously, let me just say data over there. We know V initial it's equals to V there. This is data for object B, remember. And again, we know V final it's equals to 3 times V. So if initial velocity is 5, that means somewhere after that object has traveled for that time of 1.22, its velocity will be 15. Why? Because it's 3 times V. So ladies and gentlemen, we know G it's equals to at all times 9.8. Okay, so in terms of the sign, we'll just have a look at that when we substitute into the correct formula. So ladies and gentlemen, we know this is for the situation where the object has traveled for 1.22 seconds. So now let's have a look at the question. Remember, I've read that statement which says when stone A reaches its maximum height, the speed of stone B is 3v. Guys, 3.2, calculate the speed v with which stone B is thrown downwards. So ladies and gentlemen, I'm going to ask you a question. Please do unmute your mic. Here comes a question. According to question 3.2, yes, are they asking us to calculate V initial or V final?
V initial.
Any reason for that?
Because they're asking us to calculate V, not 3V. 3 times V, I mean.
It's correct. They want us to calculate V initial name. So the reason to that, it's on this question where they say with which stone B is thrown downwards. Nay. So this is the reason why we are calculating for V. Nay.
Yes, sir.
Okay. So I was just trying to think of an example of how your answer is structured. So let's say it's more like they are saying between a Desmond and a who is it Amogelang, who is correct in answering a question. So according to you, or according to the way you answer the question, it's more like you said Desmond is correct, and they say, why are you saying Desmond is correct? Then you say it's because Amogelang is wrong. So can you see, do you have an understanding of how you provided your answer?
Yes, sir.
Okay, so now let's proceed in answering that question. So I'm glad you are able to notice exactly what we are calculating. So now let's go to our formula sheet. So now let's have a look at that formula that has all of this information. So let's check the first formula. Can you see we've got V final, we've got V initial, we've got G, we've got time. So in this case, we are going to substitute the V initial and the V final in a form of a V and then calculate for V. So this is the formula that we are going to be using. So it's this one of V final is equals to V initial plus G change in T. Remember, assuming upwards to be a positive. So obviously, because object B it's being thrown vertically downwards, that means we're going to have a negative velocity. So that means when we substitute, we're going to have negative V. Why? Because V or the velocity or the direction of object B is vertically downwards, and we assume upwards to be positive. This is equals to, ladies and gentlemen, that V initial over there. But I want you to notice something. Remember, guys, our V final in this case is 3V. I'm not sure if it makes sense, ladies and gentlemen. So I just wanted you to get confused a little bit over there when I substituted V. So it's very, very much important that when you substitute, you check if you're substituting with a V final or V initial, meaning this is negative 3V. Why? Because 3V is your final velocity. Why negative? Because we assume downwards to be negative. So ladies and gentlemen, initial velocity is going to be negative V. Why? Because it's being thrown vertically downwards. Massively important, ladies and gentlemen. So now, in terms of the sign over there, it's that sign of a positive. What about G? So obviously, G, it has to be negative 9.8. Why? Because G is in the downwards direction. So in terms of the time, ladies and gentlemen, what is what is the time? Obviously, we know the time is 1.22. And remember, guys, time is a scalar quantity, which means it only has a direction. Okay, massively important, ladies and gentlemen, that you substitute correctly. Any question?
No, sir.
Okay, someone unmuted their mic, so I thought there was a question. So obviously, you saw for the unknown, which is V. So let's try to do some calculation. Obviously, we've got negative 3V, so we add a V, you transpose it, changes the sign. This is equals to negative 9.8. Remember, this is being multiplied by 1.22. Obviously, the whole of this is a negative 2v. This is equals to, because it's negative 3 plus 1 is negative 2v. Then you can punch the whole of this on a calculator, or otherwise you can just leave it as it is to avoid having to round off before you get to the final answer. So obviously, you've got your v, you divide by 2 on both sides. So that means you've got negative 9.8, you've got 1.22. This is being divided by negative 2. So ladies and gentlemen, an answer that you get when you punch this, you're going to get the magnitude of velocity v. So I'm not sure of what you get when you punch all of that. So let me also punch on my side. Let's see, negative 9.8 multiplied by 1.22 divided by negative 2. So I'm getting 5.97, of which I can say it's 5.98. Ladies and gentlemen, meters per second. Very, very much important, guys. So I'm not really sure if you're also getting the same answer. Can someone try to confirm if you're also getting the same answer?
The same, sir.
Okay, great. So now, in terms of the marking, obviously, this question, how many marks was it allocated? I think it was allocated, was it 4 marks? Yes, so this question was allocated 4 marks. So let's check exactly where do you score those marks. Obviously, for identifying the correct formula, they give you a mark. Okay, and again, they give you 2 marks for correct substitution, and again, they give you a 4th mark for the correct answer. So ladies and gentlemen, the whole of this step is just simplification. So you're not given any marks for simplification because they know you already know how to simplify. You already know mathematics. So ladies and gentlemen, I'm going to remove all of this. And then from there, we're just going to use positive sign. Obviously, assuming what is it? Assuming a down as negative. Ladies and gentlemen, wait. On the calculation that we have just done, we assumed, what did we assume? We assumed positive to be upwards, isn't it?
Yes.
Which means for this second calculation, what are we doing? We are assuming downwards to be positive, isn't it?
Yes, sir.
Yes. Yes. So we're assuming downwards to be positive, which means we're going to have positive 3v, which is equals to v plus 9.8 times as 1.22. So obviously you transpose, you've got 3v minus v, it's equals to 9.8 multiplied by 1.22. Obviously on this side you've got 2v, which is equals to 9.8 multiplied by 1.22. You divide by 2 on both sides. Why? Because you want both to cancel and remain with just v, of which when you divide, it should also give you that same answer, ladies and gentlemen, which is rounded correct to 2 decimal places. Ladies and gentlemen, why did I round off this answer correct to 2 decimal places? Remember, you are given instructions where they say, if it is not indicated, ladies and gentlemen, round off your final numerical answers to a minimum of 2 decimal places. So because for that question they did not specify to say round off to 2 decimal places or round off to 3 or to 1, if they did not specify round off to 2, why? Because of that instruction in the question paper. Ladies and gentlemen, the same criteria has been used when marking this question. So ladies and gentlemen, I'm sure we are more than one in this lesson. Are we all happy so far? Is everyone happy?
Yes, sir.
Yes, sir.
Okay, so now can I remove all of this? Then we move to question 3.3.
Yes, sir.
Yes, sir. Yes, sir. We
Okay.
can move.
Okay, so I assume my explanation is easy to understand. So ladies and gentlemen, question 3.3 says calculate the height. Which height are they talking about? So this is that height that they are talking about. This might be a bit tricky, but let's just read through that statement. At the instant stone A passes its initial position, on its way down, stone B hits the ground. This is an interesting question, ladies and gentlemen. You need to be very careful of this type of information. So, ladies and gentlemen, it's very, very much important. It's massively important that at all times you draw a sketch, because any additional information that you get, you are able to then edit on that sketch that you're having. Ladies and gentlemen, they say at the instant stone A passes its initial position on its way down. Massively important, guys. On its way down as it passes that. What do we know about that? We know the whole of that trip for it to get to that point, ladies and gentlemen, that is after it has traveled for 2.44 seconds. Obviously, same time to go to its maximum height, same time to go up to that same level, takes 1.22 for it to reach its maximum height, takes the same time for it to reach that same level over there. So what happens when it reaches that same level? Something interesting happens, ladies and gentlemen. Stone B hits the ground. Stone B hits the ground. So that means it takes 2.44 seconds for stone B to travel from that point to that point over there where it strikes the ground. What do we know about B? We just calculated, ladies and gentlemen, the V initial of this B, it's 5.9 4.98 meters per second. I'm not sure if you remember, ladies and gentlemen, but I remember very well that the initial velocity calculated from the previous question, it's 5.98 meters per second. Guys, at all times, remember, you will always have the gravitational acceleration. So it's more like you just need to stress about two quantities, and the third quantity is your g. Then you can calculate for the fourth quantity. So, ladies and gentlemen, one of the learners who attended the lesson for yesterday, they said, their eyes are now opened. They are fully able to understand that this chapter is not really that much complicated, but it requires an understanding of the situation. It doesn't matter whether you're dealing with graphs, doesn't matter if you're given a sketch similar to that one, doesn't matter whether you're given only the statement. Ladies and gentlemen, you need to visualize the situation that you're dealing with. So obviously, this sketch may look a bit complicated, but because you started from the beginning of this lesson, it doesn't really intimidate you in any way. You fully understand what's going on over there. Remember, guys, you just need three quantities. Do we have those three quantities which we can use to answer that question? An answer to that question is yes. What do we have, ladies and gentlemen? Initial velocity. What else do we have, ladies and gentlemen? The time it takes for that stone bead to hit the ground. Where is that time coming from? It comes from that information where they say for this object to go up and down to that same level, that's when stone B strikes the ground. Massively important, ladies and gentlemen. The third quantity is G. Okay, now that we've got the third quantity, it means we can be able to calculate for the fourth quantity. Guys, before I do this calculation, are we all on the same page? Or is there someone who's got a question, ladies and gentlemen?
We fine, sir.
Okay, great. So now let's go to our formula sheet. Let's go to our formula sheet. This is the formula sheet. Remember, we know we've got a time which is what is it? It's 2.44 seconds. We know again we've got G, it's 9.8. Remember, for now, I'm just saying 9.8. Depending on our decision to assume up or down as whatever, it's going to influence the sign for that G. Very, very much important, ladies and gentlemen. And again, what else have we got? We know the initial velocity of that stone B is 5.98 meters per second. Okay, what are we calculating, ladies and gentlemen? Delta Y, which is the same as H. Is the same as H, ladies and gentlemen. It's what the question wants us to calculate. So, guys, what does it mean when we calculate for H? It means in the end, we have to say H, it's equals to whatever, ladies and gentlemen, in meters. Guys, the SI unit, the international symbol unit for measuring height, distance, displacement in physical sciences, it's in meters. Ladies and gentlemen, for some reason, if you're given something which is in kilometers, millimeters, centimeters, convert it to meters. Guys, you might be given a velocity in kilometers per hour. Good people, convert it to meters per second. Massively important, ladies and gentlemen, that you are able to perform those calculations to convert from one unit to another. So guys, let's look for that formula. So I was actually trying to explain all of that so that I give you an opportunity to look at those formulas and try to to identify the correct formula. So a re ke bone or na le mang mo lining Puti, which formula are we using? So we've got formula number 1, 2, 3, 4. Which formula can we use? Okay. Libra, is it Libra? Libra. Which formula can we use? Linda, is that you? Are you there? Is it Linda or who's
I'm here, sir. But I'm not
which?
sure which formula to use.
Okay.
Sir,
Lebo, can you give it a try?
sir, I think it says change in y is equal to vi, change in t plus 1 over 2a, change in t squared.
Okay. So, ladies and gentlemen, the reason why she chose that formula, it's because that formula has got all of these variables. Remember, guys, you need to have three three known variables for you to be able to calculate the fourth variable. So when you have a look at that first formula, your V final, V initial, gravitational acceleration, change in time. Can you see? It doesn't have that height that you want to calculate. And again, you can still use I think maybe that formula. You might find that even if you use that formula, it might work. Why? Because let's see. Oh, it seems like it's a bit tricky with that one because we don't know the final velocity of object B as it strikes the ground. So we can just forget about those two formulas. What about that other formula? So ladies and gentlemen, you might find that we cannot use this formula. Let's see, delta y is what we're looking for. V initial we have, but V final we don't know. Change in t we know. So this formula, if we try to use this formula, we're going to have two unknowns. But with that formula, straight away we just plug and solve for the unknown. Sometimes you might also perform a lengthy calculation where, for example, you use that formula, but it might be a complicated and a lengthy calculation. Otherwise, for example, you can use that first formula. Obviously, you'll be using that first formula to calculate for V final. So you know V initial, you have G, you have time. You can use that formula to calculate V final. Then you use that V final on this formula. So that means you're going to use two formulas. That's what I'm saying. In some cases, it could be a lengthy calculation, whereby if you just use that one, straight away you just plug and you solve for the unknown. So now, ladies and gentlemen, I'm going to use I'm going to assume one direction. So it's going to be your homework to perform that calculation assuming the opposite direction. So in my case, I'm going to assume a downwards to be positive. So obviously, who's your name? Who said we can use that formula?
Sir, Lebohang.
Who was? Okay, all right. So Lebohang, This is the formula. So now let's plug. What is the initial velocity? Remember, I assumed downwards to be positive. So that means it's going to be positive 5.98. And then change in t, it's obviously 2.44 plus, let's see, 1 over 2 g, it's in the same direction as the initial velocity, then it's going to be 9.8, and again time is still the same time, and remember to square that. So ladies and gentlemen, when you punch all of this on a calculator, what answer are you getting? Whoever gets the answer, please do let me know what answer you're getting. Plus 0.5, which is half, 9.8, 2.44 squared, 40 that point that. So ladies and gentlemen, what answer are you getting?
Sir, it's 43,76.
43, who is it? Is it who got that answer?
Oh, wait, sir, it's wrong.
Is it 43?
No, I'm wrong.
Who says they are wrong? What answer are you getting? Okay, Amrelang, what answer are you getting?
I got 43,76.
And the other one who said they are wrong, is it still you, Amu?
Yes, it is.
Okay, so it's 43.76, ne?
Yes, that's the answer I got.
So what is the unit?
Meters.
It's in meters. So remember, guys, this question, it's allocated. How many marks was it? Was it 3 marks? I think it has to be 3 marks. Let me check. Yes, it's 3 marks. So obviously, you know your first mark is going to come from you choosing the correct formula. The other mark is going to come from correct substitution, and your last mark is going to come on your final answer. So ladies and gentlemen, do you guys have any questions so far?
No, sir.
No, sir.
Okay, so now let's move to question 3.4. 3.4. So 3.4 says sketch velocity time graph. Very, very much important, ladies and gentlemen. Velocity time graph. This is exactly what they want you to sketch before I even read all of that. Remember, guys, just in case if you're now starting to understand this chapter, there's a lesson that I've done on my website, ladies and gentlemen. It has all the information that you need to know in relation to this chapter. So please, I encourage each of you to watch those lessons. If you go to my website under grade 12 physical sciences, I think it's up to 7 lessons where I teach the basics, all the information that you need to know, and most importantly, all the types of graphs. I'm talking about velocity time graph, acceleration time graph, and I think the other one is a displacement time graph or something like that. So ladies and gentlemen, if you can watch those lessons, I'm telling you, you will never go wrong with this type of questions, because all this information that I'm applying is based on those lessons. So, ladies and gentlemen, making use of those same, that same information from those lessons, I'm going to answer this question. Sketch velocity time graphs for the complete motion of stone A and B on the same set of axes. Label your graphs for for stone A and B clearly. Show the following on the graphs. Very, very much important, ladies and gentlemen. You must show all of this on your graph. The time taken for stone A to reach its maximum height. That is the time. The velocity for which stone B is thrown downwards. So, ladies and gentlemen, for the last time, sketch velocity time graphs meaning two graphs, for the complete motions of stone A and B. Most importantly, for the complete motion of stones A and B on the same set of axes. Guys, on the same set of axes. Clearly label stones A and B on the graph. Ladies and gentlemen, let me use this. Obviously, this is how you would start to draw. Obviously, this is the time, this is the axis for the time in seconds. Very, very much important that you indicate the SI unit. Then there say velocity, which is in meters per second. Okay, so that means the vertical axis represents the velocity, which is measured in meters per second. We know that point there is 0. Okay, so guys, there's some important information that we need to show on the graph. The time taken for stone A to reach its maximum height. We know, ladies and gentlemen, it takes what was it? I think it was 1.22 for that stone to reach its maximum height. Obviously, it takes that same time for it to reach that same level from where it was thrown. So that means from that point up to its maximum height, it takes 1.22 seconds. For it to come down to that same level, it still takes the same time. Remember, a complete journey of object B, it doesn't go up and stops there. No, it goes up, reaches maximum height. On its way down, it passes that level until it also hits the ground. So obviously, by that time when it hits the ground, you'll find that B already is there waiting for that object. Okay, so that's why there, obviously, it's 1.22 plus 1.22. It makes it 2.44. Okay, so ladies and gentlemen, what about stone what about stone B? The velocity with which stone B is thrown downwards. So that means on our graph, ladies and gentlemen, we need to show two graphs. But most importantly, we need to show these two. Okay, and remember, you need to make an assumption also when you draw these graphs. So I'm going to assume upwards to be positive. So guys, as part of your homework again, I'm going to draw this graph assuming upwards to be positive, and you're going to do your homework assuming downwards to be negative. So ladies and gentlemen, let's have a look at stone A. Obviously, we know its initial velocity. What was it? I think it was 12. So let me just start that line somewhere a bit down, maybe somewhere there, and say this is that 12. what is this 12? Is 12 meters per second. Okay, so most importantly, guys, you've got an option to have this graph going in that direction or in that direction. What influences the direction in which you should draw your graph? Is it in that direction or is it in that direction? Ladies and gentlemen, it has to be in that direction. It has to be in that direction. Why? Because as time goes on, ladies and gentlemen, as time goes on, its velocity decreases until its velocity is 0. So that is the reason why this graph, it goes in that direction, to say as time goes on, from where it was initially projected at 12 meters per second, its velocity decreases until at that point where it's 0. So from there to there, ladies and gentlemen, it's like this object from there moving upwards as its velocity decreases until it's 0. So now I'm going to draw for that portion where it goes down up to that same level. So ladies and gentlemen, this is that portion now. It's being extended up to there. Why up to there, ladies and gentlemen? Is because we know same time taken to reach its maximum height will be same time taken for it to reach that time, which is the same time as that time from there to there is 1.22, from there to there is 1.22, which means obviously, ladies and gentlemen, it means here we've got a negative 12. Okay, why negative 12? It's because it's still the same magnitude. It's still the same magnitude, but in the opposite direction. That is the reason why even on this line there, I'm not drawing it in that direction, but I just extend it in that direction. Why? Because it's now on the other side of the axis, whereby here where we've got positive, that means this is where it's in the direction of the upward movement. Okay, so that means that line from that 0 line up to there, it represents the object in the upwards direction. And then from that 0 in that direction, it's in the downwards motion. So remember, guys, something very, very much important. This object A, its journey doesn't end there. Okay, so it continues going down until it strikes the ground. At what time, we don't know. How long does that object A take to reach or strike the ground? We don't know. So for that reason that we don't know, we can just extend this line, ladies and gentlemen, and just leave it somewhere there. As long as it passes that point over there. Why does it have to pass that point over there? It's because, ladies and gentlemen, on the question they said a sketch velocity time graph for complete motions of object A and B. So if we draw this graph from there, it goes to there, up to then, and we leave it there. It's more like the complete motion of object A is from there all the way up to there, and it just hangs somewhere there in the middle of the air, of which we know that is highly impossible. So obviously we know this object is going to continue going down with its motion. Okay, so that is the reason why from there this line is extended up to somewhere, wherever, ladies and gentlemen, as long as you can pass that point, to say as time goes on up to an unknown time, that object, it also continues with its journey and it ends somewhere there. Okay, massively important, ladies and gentlemen. So now let's represent object let's represent object, which one? Object B. So guys, what is the initial velocity of object B, which is what the question wants you to show on the graph? The initial velocity of object B is 5.9 meters per second. Okay, so ladies and gentlemen, on this graph, where is 5? So obviously, if there is 12, then 5 could be somewhere there. Okay, doesn't really need to be that 100% accurate, but it shows that you fully understand that you cannot have 5 on this side. Okay, so again, we know very well, ladies and gentlemen, we know very well that it it takes what is it? It takes 2.44 seconds for object B to complete its motion. Remember, previously they said at the same instant this is being projected vertically upwards, object B is being thrown vertically downwards. When this object A moves up and get to that same level from where it was projected vertically upwards, we know that what is it? B, that's when B strikes the ground. Okay, so for that reason, it means we know that it takes 2.44 for stone B to strike the ground or to complete its a motion. So that is the reason why this line is in that direction, ladies and gentlemen. That is the reason why it's in that direction, and we can just end it there along that time. Okay, very, very much important, ladies and gentlemen. Why is this graph in that direction and not in that direction? Is because I think I'm running out of battery, ladies and gentlemen, but luckily we are almost done with this lesson. So the reason why it's in that direction is because throughout the journey of that object, it's only going downwards. There's no change in direction. And most importantly, ladies and gentlemen, this line, it shouldn't be in a funny slope. Maybe, for example, draw it like that, crossing that, or maybe draw it like that. It has to be in the same slope as that one. Why? Is because G for object or stone A and B is constant, or otherwise is the same. Okay, that is why the slope has to be the same. Ladies and gentlemen, massively important. Remember, guys, they said clearly label your graphs for stone A and B. So obviously we know this is for A and this is for B. Okay, so ladies and gentlemen, before I finalize this lesson, I'm not sure if there's someone who's got a question, but you can just prepare yourself for a question. So I'm just going to show exactly where you score your marks. Obviously, for showing that time, you're going to score a mark for that time and not that one. Why not that one? Because they said time taken for stone A to reach its maximum height. Okay, massively important, ladies and gentlemen. And again, initial velocity for stone B, you are also going to score a mark for that because they said you must also show it. Okay, and again, ladies and gentlemen, for obviously indicating that you've got parallel lines. These are parallel lines, ladies and gentlemen, for A and B. They are also going to give you a mark for that. Okay, and again, ladies and gentlemen, I think they might give you another mark for generally having the correct representation of what the question wanted you to calculate. So they are not that much strict on the criteria for marking this question as long as you've done exactly what they wanted you to do. So ladies and gentlemen, before I wrap up, is there someone who's got any question?
No, sir.
So, guys, mhm.
So, sir, you said that G of this stands for gradient, right?
Sorry, no, the G stands for gravitational acceleration.
All right, sir. So my question was that, is it possible that we have somehow to calculate the gradient?
So, for you to calculate, wait. Because now it's more like it's an additional question or it's a new question. So you're asking, is it possible to calculate the gradient? And again,
Yes.
I'm going to ask you, why would you want to calculate the gradient? Are you asking just in case if it's an additional question, or maybe you want to know how to calculate the gradient for this graph?
Yeah, I was asking, sir, if it's an additional question.
Okay, so ladies and gentlemen, for tomorrow's lesson, I'll be doing analytical geometry, where I'm going to include some ways in which we calculate gradient. Remember, gradient, the gradient, let me just use that G. Gradient is change in Y over change in X. Okay, so in this case, what is represented by change in V? So it's obviously change in V. This is what is represented by the vertical line, which is change in Y, over change in what is represented by X. It's obviously time in that case. What does it mean? It means change. I've just explained it's delta, which means final minus initial. So because it's change in V, it means it's V final minus V initial, which is time final minus time initial. Okay, so guys, if you want to calculate the gradient of this graph, you must be having the velocity final. For example, if you know what that final velocity is for object B or stone B, you can use that information. I'm not sure if we have calculated it or not, but assuming that we calculated it previously, because obviously, Libra, this question, for you to ask this question, that's if on the question paper we are given enough information for us to calculate that. So I'm just trying to say, even though you've asked this question, it doesn't mean we'll be having all the information in order to be able to calculate for the gradient. I hope you understand me on that part, isn't it? So V final, let's say V final of B, we know whatever the value that it is, minus V initial, obviously we know it's that 5 point something. Then you'll say divided by what is that T is 2.44 minus a time initial, it was 0. So if you know this two, then you're going to punch all of this on a calculator. You are most likely to get 9.8 meters per second squared as the gradient for this question. Guys, can you see that part where I'm writing now? Can you see? Is it clear on your screen?
Yes, sir.
Okay, so Libra, do you now understand how you would go about your question? Even though I don't think I've seen a question where it might be it's a very good question, because sometimes it is asked that you calculate the gradient. But just know, when you're dealing with this type of questions, your G is it's your gravitational acceleration, of which you're most likely to get 9.8 meters per second squared. So Libra, I'm not sure if you are happy with this information.
I am happy indeed, sir. Now I fully understand.
Okay, so remember that a gradient can be calculated using that line or that one. It all depends on the information that you've got. Let me quickly try to check something. V final, let me say, let me do this. Let me say negative 12 minus 12 over 2.44. I just want to quickly check something. Yeah, can you see? Guys, I think this question, it's an interesting question, and let's just give it a full attention. So for some reasons, ladies and gentlemen, just in case if you are given this graph and they say calculate the gradient for the for that motion of either A or B. However the question is structured, just say gradient it's equals to, already we know gradient is G in this case, which is change in Y, or change in the vertical versus change in the horizontal, of which in this case is change in V, because we're dealing with a velocity versus time, over a change in T, right? This is equals to, because of its change, it means V final minus V initial, all of this over time final minus time initial. So now let's use this information that we know about A. So obviously we know that V final for A, it's what? It's 12, isn't it? So we can still use that sign to say is a negative 12. So remember, it's negative 12 because we assume downwards to be a negative, or otherwise negative is in the downwards direction. So in short, the final velocity of that motion is in the downwards direction, minus, which is that minus from the formula, the initial velocity is positive 12. What does it mean? It means the initial velocity is in the upwards direction, divided by what is the final time. This is that time, which is 2.44, minus what is the initial time? Obviously, it's 0. Libra, can you punch all of this and tell me what answer you get? I already know that since we're dealing with this, you are most likely to get a 9.8 meters per square second. Guys, can you, all of you, try to punch all of this and let me know what answer do you get? And thanks for that question, Libra. So I'm glad everyone is in this lesson. You'll be aware of this type of question and know exactly what you're supposed to do. Guys, anyone who's got an answer? Amu, are you still there? Are we still live, guys? I'm not sure if something went wrong, or are you still doing some calculation?
Yes, sir, we're still here.
Okay, whoever gets the answer, just let me know.
It's negative 9.8. Oh,
So that means,
9.8.
so is it negative 9.8 or just 9.8?
Just 9.8.
So that means in your case, you said positive 12 plus 12, isn't it? Because here, I think if you punch all of this, you're going to get a negative 9.8. I'm not sure of how you punched that on a calculator. So guys, is there someone who's also getting a positive value? Okay, so Amo, this is how you do it. You start with a fraction button, then you say negative 12 minus 12 at the bottom is 2.44 minus 0, it's equals to. Can you see? We're getting negative 9.8. Ne?
Yes, sir, I got it.
Yeah. So that is how you would answer a Libra's question where they want you to calculate the gradient. So, ladies and gentlemen, I hope that makes perfect sense. So, before we wrap up, is there any question, guys, before I close for this lesson? Are you all happy? Did it make sense? Even though you might find that you are not that good with this chapter, but my question to you, do you think this lesson did help? Did it help you in terms of understanding this chapter? Did somehow this lesson open your eyes? I just need to get a feedback so that I'm also aware if I'm not confusing you guys.
Yes, sir, it did help.
No confusion, no questionnaire. Okay, so guys, I'm inviting you for my next lesson where I'll be doing analytical geometry. This wasn't the last lesson for vertical projectile motion. We'll be doing some more of this type of questions. From this one, we'll move to momentum. I've also done a complete lesson. So, ladies and gentlemen, I thank you very, very much for joining. This is that time where I need to sign out and say, my name is Desmond, and I'm out.